Hello. Maya comes with a tiny program called fcheck, which you see working now. It's currently caching 200 frames I rendered in a pretty low resolution just recently. And what you can see is water with nice reflections and transmissions, and the water flows sort of along a curve. While it flows along the curve, it goes down, now it goes up again, so it's a swinging motion sort of. And it has nice splashes. There are two lights in the scene. One comes from the left. It's an area light, which you can see working on the right wall. And there's a surrounding light, an Arnold skydome light, where I mapped an HDR image to. The curve is visible, which is quite unusual because NURBS curves are infinitely small, but you can render them, of course. But how can you make that water flow along that curve? And that's the question I'm going to answer now. And you have to go from there in order to get a nice rendering and everything else which looks more sophisticated. Okay, here is a new scene. We need a curve, of course. So let's go to the front window and use the tab Curves Surfaces here and this tool in order to draw a curve like this. Whoops, whoops, whoops. So this is the curve. Now we need to think about how we can make this sort of emit along its path. And there's a standard trick you use in computer animation very often. You create an object which you make invisible later. And in this case, I'll choose just a simple cube. And I'll scale it a little bit in this direction and flatter like this. So this is going to be my emitter. But before I make it emit water, I want to attach it to that curve. So it flows down that curve. That's easily done if you know how to do it. It's always critical what to select first and last. Of course, you can make this curve follow the cube, for example. So it would just sit there because the cube is not animated. But this is a motion path we're using now, and you always pick the slave first and the master last. And the slave is the object which is supposed to follow or to be constrained to something, and the curve is the master who dictates where this cube should go. So you select this and shift select the curve, and now you need to go to Animation. And here you have the constraints and the motion paths and attach to motion path. When you invoke this command, it will create an animation which is exactly the frame range of your time slider below, which is currently set to 120. So you can, of course, change this now or later with the option box or later. I just leave it there. So I have an animation which goes from frame 1 to 120. And which will move our box down that path. And in the next step, I want to make this box emit water. Easy. Animation FX. We need special effects now. And here we have the Bifröst fluids. And with this object selected, we create a liquid. That means we make this a liquid emitter. And now you see something blue falling down in that green box. That's the emitted water. And it just ignores the motion of our object here. Let's select the Bifröst liquid here. And here we have particles, and we could make the particles bigger like this, But instead we want to see the voxels. That's a volume pixel, so to say, and we can disable particles. So we have this kind of object here which will look more interesting when we start the simulation again. So it's more like a volume which we see now. The second thing we need to consider is that it just falls down according to gravity, and it ignores that motion. And it ignores the motion because it's finished here. It just is being created and it falls down, that's all. We need a continuous emission. And in order to do this, to invoke this, we need to pick the emitter. And this object is the emitter. So here we have emitter properties. Let's click on that tab. And here we have the continuous emission. Let's click here. And now the animation goes quite differently. Because the water is following the cube, because the cube is emitting particles all the time. What they still do is fall to the ground, and that's not what you saw in the animation I showed you at the very beginning. And that's a thing of the dynamic system here. We need to reduce the gravity. So let's see where we find it. It's right here under Bifröst liquid properties container 1. It's a property of the container, of the water, not of the emitter, not of the cube. So the gravity is currently set to 9.8 in a direction of -1 in y, meaning down. So if you reduce this to 1, you have a much less gravitation, so the water won't fall down that fast, but it will still fall down a little bit. If you're pleased with this, just leave it there. If not, you can animate this value here. For example, you can set the gravity to -10. That means with this value here, a negative value, it will go up into the air. What I did in the animation you saw at the very beginning was I used an expression here. I typed in equals, actually I can do this now, equals sign of time. Time in parentheses. So press enter. Now I have a value for the magnitude which swings between -1 and 1. It actually does swing, so it's a very miniature gravity up and down, and it's swinging very slowly because per second, but it makes the water splashes a little bit more interesting. And it will never really fall down because once it starts falling down, it will be drawn up again, like here now. So this looks already quite interesting. Now let's hide the cube. We don't need to see it. Of course we need it in the scene. I press H, so it's hidden now. And now I can render it, but I need a light, of course. And well, we can create a sky dome light. And as I said before, I did several tutorials about this. Map the color to an HDR file. Like this. It goes very fast now, I know. And now when you render it, you see the HDR file working in the background and the water splash right in here. We can make the visibility 0 of the, but still the effect 100%. So I reduce the camera visibility to 0, so the bridge won't be visible anymore, but you see all the reflections work here and transparency, etc. So this is quite an interesting thing now. Now we want a little bit more splashes, and that's a crucial value really for all kinds of water simulations. So let's pick the Bifröst liquid container again, and right here where we visited the gravity is the master voxel size. it's by default set to 0.5. If we increase this to 1, we have a much more crude and rough animation, which goes much faster. Let's go to frame 50. One further. A little bit closer here and render it. So these kind of two blobs we see now. Now instead of the master voxel size 1.0, let's go to 0.1, which is a very high resolution. It's tenfold more resolution now, and Maya takes a lot more time to evaluate this. We're currently simulating frame 21-22, so it takes a while, but you see already that the water is developing much more vividly. Let's wait until frame 50. You reduce the master voxel size at the very end, just before rendering. Maybe 0.3 will suit your purpose, and it will work much faster. The only thing we'll do after this is make the curve visible. And that's something which has to do with Arnold. It's a speciality of Arnold. Frame 46, 47, 50. So that's the same frame as before. And now we render it. And that's quite a different object, very complex. And of course, when you render the whole sequence, it's very, very vivid, as you've seen before. I want to, first of all, make the lights invisible, so we see we're not distracted by the lights. We have to select the curve. And now we go to the Arnold setting, and here is render curve. So the curve is being rendered now. And you have a curve shader. You can give it another color, for example, and the size of the curve can be increased here. It's pretty small now, but it's visible already. I don't know if it's visible with a black background. No, it isn't. So we need maybe a white background here. And now we render it again. And you see the curve in the rendering now. Well, you need to find your own way from here and enjoy the water. Bye-bye.